It's fine.
So very good morning
Okay.
to one and all present here. So we are moving on to the day 5, session 1. So before starting to the program, let me thank each and every one of you for your cooperation and your participation till yesterday evening. We have successfully completing each and every hurdles, and we have completed the up to day 4. So 12 session has been completed without any much problem. And thank you for your active participation from the entire organizing committee. So let me move on to the day 5, session 1. The session will be handled by Ms. Sini Raj from Amrita Vishwavidyapeetham, Coimbatore. Let me invite Mr. Martin for introducing the speaker.
Thank you, sir. Myself, Martin Jose, Assistant Professor, Department of Mechanical Engineering. I welcome you all to the session 1 of day 5. The topic is based on IoT applications using deep learning techniques. It is handled by Ms. Sini Raj P, Assistant Professor, Senior Grade, Computer Science in Amrita Vishwavidyapeetham, Coimbatore. She is serving as a senior grade assistant professor in Department of Computer Science. While giving about a brief description about the speaker, she completed her BTech in Computer Science Engineering from University of Calicut in Kerala and Masters in Engineering in Computer Science from Anna University, Coimbatore. Now she is pursuing her PhD in Computer Science and Engineering from Amrita Vishwavidyapeetham, Coimbatore. She served as a lecturer in Nehru Institute of Engineering and Technology, Coimbatore, and programmer analyst in Cognizant Technology Solutions. She also worked as a senior lecturer in Karpagam University, Coimbatore. She has won the various prestigious Amrita TBI Innovation Challenge Awards for the year 2017 and secured A+ grade for big data analysis in FDP conducted by Infosys. She is an active member of International Association of Engineers and Computer Society of India, CSI. She has also headed many technical events like ANOCA, ICPC, conducted at university level. She has also 2 funded projects and have 11 publications in various reputed journals. She has also participated in 5 international conferences and guided for 6 PG programs and 10 BTech projects, and has also 5 projects in collaborations with industry. Ma'am, I invite you for this lecture. Hope this lecture will be an important as well as more prestigious for every participant.
Okay. Thanks a lot, Martin and Shanmugesh sir, for such a detailed introduction. Thank you so much. Okay, so let me my sincere thanks to Shanmugesh sir and the management for giving me this opportunity initially itself. Okay, so I'm really glad to be here. To share my minimal knowledge with you all regarding deep learning, because I'm mainly working in deep learning nowadays. So. And that too, I thought, as it is a IoT series which is conducted for you for the past 1 week, so you would have already been into a lot of applications and everything by now. But it'll be really great if you could just touch upon, how you could incorporate deep learning techniques over to IoT, right? So that will be really nice. So my focus is not on basically on IoT. Yes, definitely I'll take the IoT applications, but my area of focus is basically on deep learning. That means how you could incorporate deep learning techniques so that you could make your applications better by using great algorithms, right? So that is what it is. So thank you once again, and I'll just start off. Okay. So, Shanmugesh sir, if anything, the time goes or something like that, you can always, break my session and, tell me. Okay.
No problem.
Thanks a lot. Yeah. Okay. Thank you. So let us start. Okay. So as you all know, so this you would have already seen for the past sessions, but anyway, for me to get a flow into the session, I definitely need few of these slides. So bear with me for 1 to 3 slides. Okay. So there are a lot of IoT applications which you use in your everyday life, right? So even your smart TV, and even at your home, you could always see your kids, talking with the virtual assistants nowadays, right? So I could always see my son going to the, okay, Google, okay, tell me some riddles. He'll be, kind of playing riddles. If I'm not, looking at him for some time, he's okay, he's fine. And he do have his own ways of coming out with how to utilize technology in such a way that they are not getting bored. So it has been, we are in a particular level in such a way that we have already reached a level where technological advancements have already been inculcated in our normal life, right? So we know that your smart TV, smart home, smart water heater, smart phones, so many things which we use, and we cannot even think about having a life without them, right? So going a bit deeper onto it, definitely transport and logistics. You would have seen the Samsung, the trucks, okay, which helps you. It used to have a big screens at the back side of the truck in such a way that it helps you to help you to overtake, during the night time. So it has got a night vision. It has got a normal vision, so that it helps the people to overtake without, and it has basically, the studies prove that the accidents has been reduced to a very minimal level. So there are so many things like smart cities, even our Aadhaar card is, it's kind of automated. So everything is getting automated, nowadays. You, even during the pandemic, that there are so many techniques. Even if your GPS is on, okay, it tracks you all around, okay, where you go, okay, is there a COVID-19 person nearby, okay, in how many kilometers and how many meters. So we get all the data in our hand by sitting at home. So we are all safe, and thanks to technology for that. So moving on to, okay, how, the first thing which I'm going to, this is kind of a context, okay, this is related to a context. So the context of IoT, how knowledge hierarchy can be mapped. So because, when it comes to data, knowledge is very important. So as you all know, whatever we speak is raw data, okay? So even if whatever we see, whatever we speak, okay, whatever we, generate. So even if I speak, I'm speaking in this FDP, okay? So this is kind of a data that's being generated, right? So everything and anything and everything is raw data, okay? So once you process that particular data, okay, that becomes an information, and that information is stored in our brain for knowledge for future purposes. So you all know a kid, who touches a hot pot knows that, okay, he should not touch that again, right? So when he touches this, it's just a data, okay? When he touches it, he gets the impulse that, okay, it is hot. So that is an information. So that is kind of processed, okay, cannot touch that particular hot pot. That's an information for him. And whenever he see a hot pot next time, okay, he will not, dare to touch it, right? So that's the knowledge, that's the experience, that's a collective intelligence which he has in his mind, okay, for a longer time, right? So that's kind, how our brain works. So that is exactly when it is mapped onto data in computer science or in IoT, whatever it is, okay, wherever it is, this is the hierarchy which we have to follow. So we have data, we have information, we have knowledge, and we have wisdom in the sense, like, we have some unprecedented situations which comes in front of us. Okay, it's a hot pot, but it doesn't look like hot pot also. Okay, you will be really careful. Okay, should I touch? Okay, I will touch a little part and see whether it is hot. Okay, we have some kind of a collective intelligence which we have gathered, which is nothing but our wisdom. So this is all, related to data, and we could map everything onto your IoT as well. Okay, so this is the connect between IoT and how the data works. Sensors available, right? You have humidity sensor, you have temperature sensor. Hope my internet is fine. Okay, so you have humidity sensor, you have temperature sensor. Okay, you have different types of sensors available, right? For you to do, for you to collect the data, right? So that raw data, so whatever be the data which you collect in whichever way, a camera sensor, okay, so what if we collect some video, okay, it's a data which is collected through a sensor, but ultimately what happens is that we convert it into frames. So we process it, we convert that into some numerical data, we process upon it, right? So that goes like that. So this is the typical scenario which we follow. So whatever be the data which we collect through a sensor, okay, that could be called as a raw sensory data, that is exactly similar to as your data as such. So this is the kind of the similarity. And then when it comes to information, it is nothing but more structured, because you need to definitely know, okay, what I can infer from this, from the road sensory data which I have collected. So that's an information. So can I add some more abstraction to it? So your abstraction and perceptors, which you have seen in IoT, that comes in the knowledge level, and the actionable intelligence. Okay, what am I going to finally get the insight? What is the insight? Okay, how could you use it? How could I use it for some other applications? So everything comes here. So this is the kind of the knowledge hierarchy which is followed both in the data context and both in your IoT context, right? So now, so these are all the technological challenges. So I'll better skip this slide, because I think I need to really look upon to the time as well. So this is kind of some challenges which you would have already seen in the previous sessions. So management, data diversity, so device diversity, because when it comes to IoT, you all know that it's all about devices, right? It's all about devices we have to deal with. So how the device is going to store, because when it comes in terms of data analytics for us, or data science, or whatever related to deep learning, whatever it is, we deal with data. Okay, we as deep learning specialists, we are more worried about what is the data that you are going to give. So whether you give me a camera image, whether you give me some numerical data, whatever it is, finally ultimately I'm going to convert that into numerical data, and then only I'm going to apply my algorithms over to it. Let it be textual data, let it be camera, let it be a video or photo or whatever it is. My first job of mine is just to convert that particular data into a numerical data, because only when it is numerical data I'm going to work upon that. So I don't really worry about, okay, what is the kind of the data that you being a IoT specialist is going to give me, right? It's just that. So when it comes to, so I want to make you through three different terms in the whole artificial intelligence scenario. So what is basically artificial intelligence? So I'm not going to all this blah 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 which is written over here. So you would have seen this particular lady. Okay, I hope she's lady. Okay, I prefer saying that. So she's Sophia. So you would have already seen her, right? So she's one of the first, one of the, I cannot say it is she, but she's one of the humanoid computer. Okay, so in this time, in the current scenario, she's here. She's our contemporary. Okay, so she is really famous for being the best artificial intelligence humanoid available on Earth now. Okay, and she is one of the first humanoid computer who have also come out with shown the greatest results for adaptive learning. Okay, so adaptive learning. And the next one is, she is the only humanoid computer who have got the citizenship from Saudi Arabia during a conference. Okay, so she is the only citizen in this whole world as a robot. Okay, so basically, by the name itself, it's very clear what is artificial intelligence. So we are going to infuse intelligence onto a machine. Say maybe it is an IoT device or whatever it is, right? So we are going to infuse some intelligence over to the device in such a way that, okay, we are lazy ultimately, right? We are all lazy. Say, I don't want to go there and switch on my TV. That's why we found a remote, right? So I don't want to switch on my ACs from here. Okay, that's why I'm even more worse. So that's why I have a phone all the time. So that's why I'm controlling everything from my phone. Okay, I'm lazy to switch off all my lights in my room. That's why so laziness is good, right? So ultimately laziness is really, really good, because it makes you creative. Okay, it makes you more innovative, right? Only thing is that you need to make sure that you need to use it in the right way, so that it is all good ultimately to the universe. That's all, right? So basically this AI is nothing but, okay, you are going to infuse some intelligence over to our machine, okay, so that it could be useful in a better way later for us. Okay, so there are different type of AI, and also I'm not going on to it. So it is kind of weak AI is there for a specific type, strong AI, and all the stuff. Now it comes to the broader term, that is nothing but machine learning. So how this machine learning is coming in this particular scenario? Yes, I found a problem. Okay, I found a problem. Okay, I want to make my water heater know by itself that I'm going to take bath, and it has to be at the right temperature, so that I don't waste water unnecessarily. I don't want to on my hot water pipe, then on my cold water pipe, and waste my energy and time. So my water heater has to know automatically that, okay, Sini is okay going to take bath. Okay, so this is the temperature which she likes. The outside temperature is this much. So everything has to be known. So I want to make my water heater smart. So how can I do that? Yes, I could do that. So inducing this intelligence onto a machine is basically done by using various algorithms. So machine learning as a broader window gives this ability of making a particular machine more intelligent. Okay, so it provides it lots of algorithms. It gives us a lot of algorithms which helps us to make a machine intelligent. Okay, so I want my machine to know the features in the sense like, okay, the outside temperature is 23, so definitely it is cold. So I want my water to be more hotter, right? So how can I, so what is the temperature which she likes? So what is the temperature she has actually taken bath with, for the past few days? So it has to do an adaptive learning. So all this learning has to be done by using some algorithms, right? So that is basically, so that feature extraction for a particular person or for a set of persons could be done by using the machine learning algorithms which are already available, right? So, and say if the outside temperature goes to really 0 or something like that, it's too cold. Okay, I have shifted my place. I'm in a new place now. Then also my algorithm should be able to adapt to the new temperature outside, and it should be able to predict, okay, this would be the temperature that she would be allowed to, take bath, okay, with. So that kind of an adaptive learning could be that feature extraction. That adaptive learning could be done with the help of machine learning algorithms. So we definitely need machine learning algorithms for implementing artificial intelligence over to a machine. Now, what is this deep learning? So where is this deep learning coming in? Yes, this deep learning comes in such a way that it's all basically mathematics. Okay, so don't worry by okay, my god, okay, usually usually everyone has a problem. Okay, they will be really interested and so passionate in learning something. When maths comes in picture, we will see a empty hall. So don't think like that. Okay, because our technology is so good in such a way that we don't have to directly deal with maths. Okay, but we indirectly deal with mathematics at the end of the day. So that is how it is. Don't worry about it. Okay, so it's all mathematics in such a way that, so deep learning is something, so people started thinking, okay, we need to extract the features manually by using the machine learning algorithms. Can be, so some lazy persons were there, so they started thinking, okay, can we even make that also automated, so that I don't have to worry, I don't have to spend time in manually going there and extracting the feature. So that's where this deep learning comes in. Okay, so deep learning is a technique which automatically extracts the features from the system, okay, for the system, and it helps in a super adaptive learning. Okay, so it is just basically like, so it is exactly, so how did they find this? So this technique was found exactly like, how a human brain works. Say, our parents or even our collective intelligence does not help in our normal days to deal with all the situations in life, isn't it? Right? So say if any unprecedented situation comes in, unpredicted situations comes in, we deal with that, right? We deal with that. Nobody tells us, okay, we just think about, okay, what should I do? Okay, what should I do? So if I do like that, what will happen? Okay, can I do in another way? Okay, what will happen then? So we do have a thought process which happens in between, right? So that is exactly where this in this deep learning happens. So deep learning makes the systems, allows the systems to think exactly like our human brain, or mimics, helps to mimic the brain exactly in the way, how a brain works. So that is basically what has happened in deep learning, basically. So if you want to do that, our brain is the most complex system which people, the researchers have ever seen. So they have still not able to understand what happens, just that they know that, okay, they have multi-level abstraction layers which are there. So can we use this abstraction layers to extract the features automatically? So that is the only thing which they have to end up in, and the researchers are still going on with all this. So can be, so deep learning ultimately is nothing but it helps your system or the machine which you are developing to mimic exactly like a human brain with so many layers in between. Okay, these blah blah blahs are good, ma'am. Can you explain this better? Yes, exactly. I could explain that better by, so this is the broader window. So you have your artificial intelligence, machine learning, deep learning, because when we are doing this FDPs for machine learning, if this picture is not there, then my slides are not complete. So bear with me. And then, so this is the limitations of ML. So in ML, you have to do a manual extraction of feature extraction. So you know what are features? Features are nothing but just the attributes. Say if it is a water heater, okay, what is outside temperature? What is the inside temperature? Okay, so what is the temperature she used to take bath? Okay, so all those information could be told as an attribute or the parameters which are required for your algorithm, right? So that is nothing but the features. So don't worry about what these features are all about. Okay, this is nothing. This is as simple as that. It is just the attributes which help you to run your program. That's all. Okay, so you need your, so the only thing, understand, in machine learning we need to write algorithms in such a way that it extract features. So it's, there is a manual effort which is coming in. But in the case of DL, what happens, you don't have to, you have your intermediate layers, you have your hidden layers in your deep learning, which works exactly like in your human brain, which adapts to the newer context and which will be able to adapt the features, feature extraction automatically. So this is the major difference. So this is important. That's why I'm just, spending few slides on this. So bear with me. So you have your feature extraction as a separate part, and you do have your learning as two different modules here. But when it comes to deep learning, it is all together. So you don't have to worry. You have to just give the inputs, just wait. Okay, you'll get your outputs. Okay, but maybe you will have to, do some arrangements and do some improvisations in this middle hidden layers. Later we will see with some programs and everything. So you will understand what it is. And as you make this part effective, you will get a better results each and every time here. That's all. So it has got it learns by itself. So that is a major thing which you have to understand. It adapts to the newer situations, to the newer inputs, and it learns by itself so that it gets a better output later. That's all. So this is the common structure of deep learning. So this is something which you have learned in your 8th standard or 7th standard long back. Okay, you remember this, right? I was really happy when when my teacher started there. Then at that time I never thought that I'll be working in this, in my computer field as well. So I'm so happy to the field of deep learning and my biology teacher as well. Yeah. So this is your neuron, a single neuron, right? So a single neuron has got the nucleus. So this is exactly like the central processing unit, okay, where all the processing happens. And these are the dendrites. So this is the terminal. So you get the input from here, and you have got some processing done. You have got a communication channel where axon, where the communication travels, and it reaches, once it reaches here, the next neuron is connected. So this is exactly the picture of a single neuron, how it is exactly there in our brain. So when we are mapping it onto, say, I have put internet here because I just got these pictures from internet. Okay, so this is how I exactly map onto a deep learning model. So you have an input layer, you have a hidden layer, and you have an output layer. So whenever we learn anything in computer science, right? It's like not only in computer science, even when you are mechanical engineer. So if you develop something, it's like we need to know very clearly what is the input that is going to be given to the machine, right? What is the processing that has to happen, what is the output. This is a single model that we always follow, isn't it? Right? So this is exactly the same for this deep learning as well, for any model anywhere. Okay, so you have got inputs, this is nothing but your processing unit, and this is your output. But here the processing units are called as hidden layers because it is not an easier one, it's a complex one with a lot of layers. So we have got a lot of hidden layers here. So that is why it is called as a hidden layer. We will come to it later. Now, to mathematically represent it is as simple as that. Say we have a lot of x1, x2, these are our inputs, and say as your teachers used to do for your marks distribution, right? So normally you have your internal, your periodical 1, periodical 2, then you have your continuous assessment, which comes to say 50 marks. So for your periodical 1, okay, we are giving a weightage of 15. For periodical 2, we are giving a weightage of 15. For continuous assessment, we are going to give a weightage of 20. So this is something exactly like that. So what is the weightage that we are going to give for each and every input in my whole network, neural network? And this is your summation. This is your processing, which I'm going to do. So I'm using a bias. So I want to get the exact output according to my output. This is a mathematical model. So mathematical model will never get complete without a function. So function is nothing like f of x is equal to y, right? So I'm doing some transformation upon my x so that it gives me y. That's all it is. So it gives me a boundary, like say 0 to 1 or -1 to 1. So it limits my values. That's all a function does, right? Normally it just, limits the values of the, the input values to a specific output value. That's all it is. So this is the complete picturization of your deep learning network. So you have a biological neuron, how it is basically converted into a bird's eye view, then how it is basically converted into its mathematical model. So now how simple is deep learning. So now now you have learned deep learning. That's it. Okay, done. So it's so easy. So it's nothing bigger. Now we are again moving back to, so my aim or my agenda for this whole session is, how you can utilize this deep learning, okay, in terms of your IoT data, right? That is what my aim is, or my focus is all about, right? So for moving on to that, okay, we have got a lot of sensor data. Maybe it's from mobile, maybe it's from computer, maybe it could be from cloud computing, or aeronautical data, or from some computer satellites, anywhere, or your GPS system, anything it could be, or your TV, mobile, whatever it is, your social media. So whatever be the data which I'm getting in, okay, that data is basically fed into a storage. This storage is nothing but your big data. Say, because nowadays we are not working with simple data, right? We are working with millions and trillions of data, where our normal databases, RDBMS databases were not able to, relational databases were not able to handle. So that's why we have come out with a lot of unstructured databases like MongoDB, which can handle large amounts of data. And so when large data came into the picture, they came up with another new terminology, that is your big data, where you have your Hadoop, Mahout, everything for processing, so that everything helps in your processing. So once the data is everything is fed into the big data or data warehouse or whatever it is, now it comes to the so for as artificial intelligence people, or us as a machine learning engineer, or as a data scientist, my point is nothing but just give me the data. That's all. Just give me the data and I will take care of it. Okay, I will take care of it. I'll give you the insights. You better look over to the insights and let me know whether it's okay for you. If you want something more, okay, just tell me. I could do something better over to it. So that is where this AI comes in the picture. So once you get the data, okay, so wherever from a bigger database, say if I'm going to gather the data, then I'm going to apply all my deep learning or machine learning or artificial intelligence, whatever be the techniques available on the earth, I'm going to apply that suitable for your application data, okay? And then I'm going to gather the insights or analytics out from it, so that you could predict a better, you could predict better, how your data could be used for another applications as such. So this is the whole scenario of how you are going to work. So this is kind of theory. Don't worry about all this blah 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 just tells you that you just need to take some sensor data, you just need to get some data, then I need to understand some actionable or contextual information out from it. Once I get that, okay, I do have all the big data techniques to process it, to clean it, to process it, then I'm going to apply that real-time data analysis, okay, wherein I come out with a lot of insights out from it. That's all it is. That's just written as theory. That's it. So now this is another application which you could see to make you understand that how IoT and DL is connected. Okay, so let me tell you, each and every area of research cannot stand by itself, or it cannot be isolated, and it cannot work by itself. So your IoT, your data science, your data mining, your information retrieval, okay, the NLP, everything is as connected together. So one field cannot exist by itself. That is a major thing which you have to understand. And when it comes to deep learning, so you could look here and understand that according to the previous picture which I have shown you, okay, this is exactly like this. This is kind of a neural network architecture. Okay, hope you're able to understand. This is an input layer. There are some hidden layers which comes in between, and you have got an output layer. So this is definitely some representation for your neural network architecture. What are you feeding this neural network architecture? Okay, you need to feed your neural network architecture with some input data. So where am I getting my data from? I'm getting the data from some IoT devices. So definitely it's some sensor data. So I'm getting some sensor data. I'm processing through the module. I'm getting some output. So what are the basic applications wherein I'm using? Okay, it could be some attacks detection, or it could be some early signal alarming, or it could be some very normal. Okay, the data is basically classified as, okay, there are some attacks. They are actually classified as, oh no, there are some, some alarming things are there. So be better, be careful. Or you could say that everything is fine, so it's all normal. So basically your neural network architecture could be used for either classification or prediction related data. Okay, so if you give the data as sensory data, I'm going to analyze that particular data or understand that particular data with the help of the neural network architectures available. So the major work which is done by a neural network architecture, it could be classification, or it could be some prediction, or it could be some sample data generation. Okay, say I have this IoT data. So my data set is small. So I want to generate new set of data, but which conforms to that particular data which is already there. Okay, you could use this neural network architecture for generating new samples, okay, which are not duplicate as your original data. So there are so many applications wherein you can use this deep learning architectures in between for your IoT data, right? So this is another data. See here, what happens is that, say, when it comes to deep learning, you would have seen this, okay? You would have mainly seen, a lot of data wherein we work upon image, right? Where we work upon text, right? But people have a notion that, no, IoT data cannot be used for deep learning. So normally that's a kind of the scenario where when we talk with IoT people, normally they have a notion that, hey, no, you work with image, you work with textual data. Okay, for text analysis you use this, for image analysis you use that. Okay, but how can you use it for IoT data? So people have a wrong notion of this. Understand, say, even if you get the data from a camera, okay, what is camera? Basically, camera is a sensor. So we deep learning people, take camera as a sensor. So by that particular sensor, you're using some sensor in between, and you are using that to take pictures or videos and just give it to us. Okay, that is converted into some frames or whatever it is, and we are converting it into numerical data and working upon it. So that's all it is. So even if it is some, say, you are going to automate your whole building by using some camera system, okay, you need to understand some anomaly, some terrorist attacks or something like that. Okay, some uneven, some unpredicted things which is going to happen. Then you have to definitely take the video there, right? So clippings, right? So that is given to our our model as a input. So that's all it is. So each and everything. So you cannot exclude IoT or deep learning separately. It's all inclusive, and it's all together as such. So here what happens basically is that, say, we do have a lot of sensor data, okay, which is coming over to a system, and this is basically a convolution neural network. Okay, we will see a bit about it according to the time we have. So this is the convolution neural network which happens in between. So this convolution neural network, there's a spelling mistake here. Yeah. So convolution neural network which happens here. So this convolution neural network, what it basically does is that it extracts as much of features as it can, right? So it has got multiple layers in between. So these are called as hidden layers, right? So this extracts as much of data as it can, then it is converted into a single dimensional data, then it will do the same. So this is exactly what it is done. So it predicts whether the data has got attacks, or it has got any early warning signal to be provided, or it is very normal, it's all good. So this is exactly like how the classification is done. So here it is a very abstract model. So when it comes here, we are basically applying the convolution neural network, or CNN, to classify the whole data into whether it is attacks detection, or early prediction signal, or normal. So this is how it works. So it's all as simple as that. So now when it comes to IoT, so I don't have to really worry about telling all this. So there are three major phases, as you know. So the connecting devices, you need to understand according to your application, okay, what is the IoT device that you're going to use, right? And then how are you going to collect the data? Are you getting to collect the data? Okay, once you're getting to collect the data, am I going to visualize it? Because visualizing is very important in any data analysis part. Okay, when it comes to visualize the data, because you need to visualize the data before the processing and after the processing as well. So why before the processing is it's important? Yeah, because see, always you remember movies, right, better than the photos, and the photos and the videos, okay, you remember better than how much ever your father or mother have scolded you. Okay, if you have seen a particular movie, okay, that movie had a better impact upon you than whatever your father and mother, they will have to keep on telling you, they have to keep on remind you, I have told you 100 times, you would have already heard about all this. So it's all the same. So if you have some data upon your hand, when you visualize it, okay, you will get a better impact upon you. visualize that particular data initially itself, you will know the spread and the distribution of the data. Okay, you will get the spread and the distribution of the data. You will have a clear idea about, okay, what is the outliers. Outliers is like, this is ABCD, suddenly a 1 comes, so that is an outlier. So it doesn't fit onto the normal data. So something, something weird is actually happening, right? So that is nothing but that is nothing but this outlier. You're understanding about what is the kind of the data that you're going to work with. Okay, what is the spread of the data? What is the distribution of the data? That is very important for you to work upon the data. Then only when you get an insight, okay, you'll be able to understand, oh, initially it was like this, now it is like this. Okay, so now I have a comparison. Now I can do a comparison, so I could make this whole system automated so that, now I know what is happening. So that kind of a knowledge is really important. Okay, so this is all like, okay, so basically what we does is that we take a real-time scenario, okay, we basically convert everything into numerical data. Say, give us picture, or let it be video, or let it be some numerical data, or let it be Greek and Latin, whatever it is. Okay, our aim initially is nothing but, I want to clean my data. Okay, I want to do some pre-processing upon my data so that all the unnecessary, unwanted things are taken away from that. Okay, and then I want it to be converted into some numerical value. That is my first aim. Then whatever it is, so let it be the application which you are using. So the models which you have to use always depends upon what is the object that, say, for TB data set, you need to use a specific model. For water boiler, okay, you need, because the kind of the data is different. So according to the data you are going to work with, okay, you need to decide upon the model that you're going to work with, right? So finally, you're going to apply it with some NL, ML, and DL structures. And then for connectivity, you will have all this API calls and third parties who interfaces which comes in between so that everything goes smooth, right? So that's all it is. So now I will move on to applications. To reduce my applications because I really want to. Once you see the demo, you will understand that how easy deep learning is to implement. So then only you will start working. So I really wanted to show you some demo as well. So I think I have got time till 9:30, right? Yeah. Sorry, 9 o'clock. Okay. Okay, here.
Up to 11, madam.
Yeah, 11. Okay, okay, sir. I got it. Yeah. So, so the first important applications when it comes to IoT is nothing but self-driving cars, right? So this is kind of the common example which you could see. So basically, I will be sharing this slides later with Shanmugesh sir. Okay, so you could go through the slide. So I would have given some credits. I would have given some video links and all this stuff. So when time permits, if you're really interested in this IoT applications, please definitely go and see this video. So it will, because it's exactly like what I said. So once you see the video, you'll get more motivated to how it works. I don't have time to show all the video. That's why I'm just restricting to it, but you could definitely utilize this for later. So when it comes to self-driving cars, Google's, you know about the MG Hector, right? You are seeing the MG Hector, and I don't remember the newer name of that model which has come out. Okay, so you have seen a lot of cars already in ground. Okay, with a lot of artificial intelligence inculcated in it. So you have to simply tell, okay, car, get me to this location, so it takes you there. Okay, car, you have to take me to that location, take me there. So it's already a reality for us. It's nothing new for us. But there are lots of research which happens in Pittsburgh University, which is actually the lab from Uber. So Uber has got an artificial intelligence lab. So what they are trying to implement is that, so Google cars, because it's as common now, it's not new, it's nothing new to talk about, right? But definitely the research opportunities are really greater. But still, I will tell you one thing which you would have heard. So Uber is actually basically what they are doing is that they're trying to replace Swiggy kind of operations. So Swiggy, usually, that, usually when you take the statistics of, the death rates which have, this delivery boys, in the case of the delivery box, it is basically accidents. Okay, not death, basically, the accidents which is caused by them and for them is also higher. So what happens is that they will be in a hurry, the Dominas and all, that if he is actually coming late by even 5 minutes after the half an hour, you can basically ask them, no, you are late, okay, so give us the pizza for free. So that option is available. So normally those people rush in such a way that they also causes accidents to other persons, and they themselves end up in accidents. So basically, this Uber has actually come out with a newer technology or newer research in such a way that they are coming out with cabs in such a way that the cabs takes the pickups and it drops at the location. So that there is no time bound or anything according to the traffic and everything. Whatever be the time taken, they will do that. But you have to just enter it. It automatically takes the location of the person where it has to be delivered, and the car goes to that particular place and it delivers the food or whatever it is. So that is the greatest research which is basically happening. But only challenges which you have to keep in mind is you will have a front sensor, you will have a back sensor, you will have a lot of cameras, so that the car has to know. It's not like a human being looking over to all the places. You have even seen in Kerala and Tamil Nadu and all, people take diagonal cuts. I will used to tell my husband that, people, I don't know why people take diagonal cuts in the road. Okay, why we drive, suddenly, you could see one line. Okay, by the time we understand that person has gone, he would have reached his place. So it's as simple as that. So this unprecedented scenarios definitely comes in. So how a machine could understand, okay, something is coming from side and it is not, just exactly left or right, it's diagonal. Okay, so it's definitely a new situation for the car, because as a human being, it has to learn by itself, and okay, something has crossed, it has to also understand and break the car. So how all this, and the pedestrian crossings, and in Kerala, if we see, you can see a lot of murder comes in between, the cows and dogs comes in between on the road all of a sudden with the human being. So you could so these are all different scenarios. So when we take this automatic cars or self-driving cars in countries, in foreign countries where the lane traffic is strictly followed, then okay, then it's fine. But when it is actually, see, just imagine when it is applied over to an Indian scenario, but there is only one line where most of the people will not stick onto the rules. Okay, then you should understand the kind of the challenges that is going to pop up. So each and every scenario actually could be taken as a point of research from your side, and you could just work upon it. Even you could start working upon the geo mapping. Okay, how you could identify, how you can the traffic intensity during a particular time at a particular traffic area. So there are a lot of applications which you could basically look upon from your BTech projects to your major research projects. Okay, you could just try thinking about. So whenever you take a project, I will always say that don't search anywhere, look around. Okay, open your eyes and look around to get the projects. Then only you will have that passion to work upon it. And being a mechanical engineer, you have n number of scenarios for that. The only thing is that you have to just identify, okay, this is the option, this is the problem, and you have to start doing it, right? So don't ever look over to any paper. Okay, you can look over to you can do your survey research, everything later. But for getting a particular problem, what you have to do is that you have to just observe, okay, what is happening around. Travel. Okay, when you travel, when you speak with someone, when you do something, when you go to a new place, you have to just observe. All the problems are there just around you. You have to just pick up the right one and start doing it. That's all. And the next one of major IoT applications is that emotion detection. Okay, so normally there is a company called Emoticon. Okay, it's one of the oldest company which is available there. Okay, so this company, what they have done is that it's kind of an MIT research which has happened. So what they have done is that they need to know how the students feel. Okay, it would have been really nice if I have implemented that for this in FDP. I think early morning, the first session. So I hope everyone are fresh. Okay, so see, it's an emotion detection. So even for the online class, if I could understand the face, if I can detect the face of the persons, and if I am able to understand whether they are happy, whether they're sad, whether they're drowsy by your lecture, okay, and I get some feedback about the each and every participant. Okay, so this is basically done as they capture the video of their video of the students, okay, in the class, and then they identify the different emotions which comes in. So when the person is lying down, he's sleepy. When the face is really like drowsy, okay, he's very boring. So there are so many emotions which are identified, whether they are really interested, okay, whether they're asking questions, so their facial expressions are taken. And so there are a lot of research which is going on in that. It is good applications for IoT as well. And then the next one is natural language processing. So for speech sensors, so you have already experienced this. So so please see this video later. It's very interesting. So what happens is that when you speak, I have seen my mama using this Google Voice. Okay, long back, I was just wondering, like, the first time when I saw, I was just wondering what is she doing with the phone. She was just talking over to this phone, and I want Narayaniyam, okay, something like that. She was speaking on. Then I initially thought like she's speaking to the friend. Then she was telling like, you have Google now, you don't know that? Okay, then I was like, oh my God, she knows, she uses only voice search. I've never seen her typing. So this is the kind of the technological advancement. So the voice signals are taken, the voice signals are converted into its text. Okay, and that text is basically used for the Google search engine for searching. Okay, it takes the data from the server and it gives back to me. And you have Google Translate, right? You have Google Translate, which helps you to do a better thing. So even if you travel to a new place now, you don't have to worry. Normally when we used to travel initially, we have to at least know, okay, how to say thank you, how to say hi, how are you, where to go, at least something we have to at least find out. Nowadays we don't have to worry going to a new place, we have Google Translate. So this happened to me one time when I went abroad. So they gave me a feedback form wherein it was all written in Arabic. I was not able to understand what it was. So I just took a photo and I used the Google Lens, and it was there. It was just email address, but it was Greek and Latin to me initially. So it is as simple as that. So this is how the technological advancements has happened. So you don't have to even rely upon or asking someone, okay, what is it? You don't have to even get the help because your help is already there with you. You have to just understand, okay, there is someone to help you there. That's all. So it's all about, so everything. So when it comes to your IoT, it's all sensor data. So when I speak, it's data. Okay, that data is basically taken. When it is text, it is data. That's all. So that is the raw data which you're going to work with. Your virtual assistants, exactly like your. So this is an advanced example for your, or inner example for your NLP. So Alexa to Siri. So all this. So there will not be a single person at least who have tried using your virtual assistants in the phone, right? So this is kind of an example. One second, I have to stop my pointer, I guess. Then only this will work. Yeah. Sorry for the convert 172 inches to centimeters.
172 centimeters is approximately 67.72 inches.
So it's as simple as that nowadays, right? So this is an example for your voice to text conversion, which has happened, right? And your Google Assistant, right? So this is, will it rain today in Coimbatore? So it just gives me the whole data, okay? What has to happen or what is there. So it's all about your voice sensors, which happens in between. So this was kind of a chatbot application. So wherein I was just funnily chatting with the chatbot, okay? So do you know my name? Is this, see here, so it gives me the replies in such a way that it exactly gives like a normal human being, right? So funnily enough, okay, Rehan asked a similar question to us. Okay, tell me my name. So can you call me Sini? So it's kind of, a very normal conversation, which as if I'm doing to a human being. So if I don't know that it is not Google Assistant, I will not ever know that it is not a human, it's a robot, who is doing all this behind. So you have seen this picture Avatar. I don't know, how many people have not seen it. So this Netflix and Amazon recommendations. So I'm not worried about Avatar now. So I'm just worried about the recommendations. I'm concentrating upon the recommendations here. So you have a lot of data. So when you do Netflix, or when you see Netflix or Amazon Prime, or Prime Video or Hotstar, the kind of the data which they take from you, and the kind of the recommendations. Say if you are actually a person who see a lot of money heist and kind of investigation movies, okay, then definitely all the recommendations which comes to you will be basically what kind of the similar personalized recommendations. This you would have seen the so hope you would have at least heard about this, right? So this is kind of the convocation which has happened digitally, okay, in IIT Bombay. Okay, so the professors were there, the kids were coming, they were getting, okay, you could also suggest to your management if they are not sorry for that, Mosan Shanmugesh sir, okay, so you could also ask your management to come out with a digital avatar, kind of a convocation from your institution as well. So this is all possible, right? And this is really wonderful. So this is kind of the convocation which has happened digitally, okay, in IIT Bombay. So this is really wonderful. Okay, so this I really want to share, which has basically done in the field of IoT. This is the paper, okay, which I have come across in deep learning and IoT. So that's why I've specifically taken this. So here, what they have done is they have recorded the videos. I don't know whether it will work. One second. One second. I don't know whether it will work. I think my network is really slow. So I'm so okay. One second. Wait. I think I have my video downloaded here. Second. I hope I have time. Where is Vishwajyoti? One second. Sorry for the delay cost. Yeah, I have it here. Okay. So this is not done by me.
Distinctive sounds when you hit and scratch them.
So see here, what they are basically doing is that they are actually coming out with their sensor data. So the sensor data here is nothing but the voice sensor here. So understand that's why I specifically took this one example.
These sounds can tell us how objects behave when we physically interact.
So what they have done is they have collected kind of different type of voices from different scenarios. Okay, different kind of voices from different scenarios, and ultimately what they are doing is that they are going to predict. They are going to predict. Say if there is a particular scenario but there is no sound, so they are superimposing the sound over to a new scenario, wherein you will not be able to say whether it is a real sound or the fake sound. Hope you are following me. Okay, so what they have done is they have collected a lot of sounds through some voice sensors. And what they have done is that they have mapped these sounds to some particular scenarios where there is no sound at all, and the human beings were unable to understand whether the sounds which is superimposed over to a unreal scenario is fake or real. They were not able to understand. That was a whole area of research. So you could see. So in this particular example, he is actually striking on this bush, but that sound is basically taken from another audio clip. Wherein they have actually taken it from another scenario. So these are some examples wherein beautiful, interesting examples. So if you're really interested, please go through their research. It's a beautiful research, and it's an see all these things.
Our algorithm can get confused when the motion of the drumstick resembles a hit, but it does not actually strike a surface.
See here. So here there is a confusion. This is kind of a challenge which they tell. So when they touch when they touch the chair, there is no sound. You see here. So you could just notice that. So later on, I have given the YouTube video over to this. So just go through. This is an interesting example. So there are some challenges as well. Wherein when you get the sensor data, so whenever you work with some particular data, always understand that what is the kind of the challenges that is there inside as well. So this is kind of a beautiful example. So the video and everything is given there. So you could just go around and look around that what the video is all about. Then another major thing is the visual recognition. This you would have already seen commonly nowadays, right? So this is kind of a scenario wherein my mentor is Dr. Sriram. So he has basically come out with this I think come out with this I had that real video, sorry, where it is now. So he has actually come out with this real-time application wherein how closely the say in a particular traffic scenario, he has used sensors to understand that whether you are at a reasonable distance between the cars, or whether you could overtake, whether you are safe to overtake or not safe to overtake, and all this stuff. So there is a, if time permits, I will show that video at the end. So this is kind of an interesting example where very commonly people use. So it collects it's just a video sensor where it collects the data. It identifies that these are all the cars. So at that particular the prime time of a traffic, the cars are more. Then the bicycle is less, then the pedestrian car, it's a person, so the pedestrian crossing will be less. So all this analytics could be used for as an application. So here I'm just telling you the broad view applications. You can dig around in that, and you can dive deep into it, and you will get a lot of narrow down applications over to it. Then another major applications of IoT is nothing but dealing with helping the children to deal with the developmental delays, say whether it is autism or whether it is some speech disorders or whatever be it. So if you are able to identify those things early and help them with the help of an IoT device. So there is another major project from my mentor, where he won this Hack Harvard award. So wherein he actually uses the early, what is it, the elderly fall detection. Okay, so if a person is falling, and because in normally in US scenarios and all the foreign countries, what happens is that the elderly persons, live all by themselves. Okay, there will be nobody to take care of them. So what happens is that in the colder, when the winter comes, what happens is that nobody will be taking care of them. They will end up in depression, they will fall somewhere. So even if they are dead, nobody knows about what is happening to them. So that is kind of a project which he has taken, and he has done won the award there. Okay, so where he basically used the IoT model to come out with how they can actually help. So these are all some, and they have actually come out with another project wherein it helps the autistic student to virtually learn, and they can pick up it's kind of the AR, VR, and IoT and the deep learning combined together, where they can take like the Shifu globe. Okay, Shifu globe itself is not good, but still, so kind of the Shifu globe wherein you can pick the data in Byju's classroom, and all you could see, you could take you could take that heart. If you're learning about the heart, you could take the heart in your hand, you can turn around, you can see the arteries. Okay, you could see everything by yourself, and it helps the people to understand, or children to understand how it is really. So it helps even in our pandemic time for the drug discovery, for artificial intelligence, medical imaging, whether to understand whether the cancer detected data. So they're all X-ray data. So when it comes to X-ray data, it's all sensory data. So understand the data which we get from any machine. That is basically, we in deep learning are considered as sensory data. So all the X-ray images which you are working with, okay, then you have to understand the image, because already the image will be kind of blurred, right? So from that image, you need to identify whether it is benign or whether it is okay, right? Whether he has got some cancerous cells or not. So identifying that, so applying various deep learning algorithms. So all those happens from long time. Okay, so I will just, so fraud detection, right? So if you are putting the things over to a ATM, and there are transactions which are happening in your account, but if there are some suddenly different transactions which happen, which where you have to definitely look over to some outliers which happens, then how can you? And the blockchain, when the blockchain comes in picture, IoT is already there. So personalization, so there are so many things. Okay, so I'm just moving around all this. So pixel restoration. So in pixel restoration, how IoT comes? Okay, you are basically taking the pictures or gathering the pictures by using a video or a camera sensor. So that's all it is. Say if you have a camera, 365-degree camera or a grayscale camera which is fixed upon in your room. Okay, we have basically done an example earlier, project earlier in Amrita. Okay, that is nothing but elephant detection project. So in the elephant detection project, early elephant detection, because normally when it comes to this, areas like Manandavadi and Etimade even, okay, kind of Wayanad kind of area, what happens is that they feel, the farmers usually struggle by losses, not because only of the climate there, but the animals poses a lot of issues. And the majority of the issues basically happens with the help of this with the issue of this wild elephants which comes over. So, and we cannot even see the elephants, and whether they are because they look very similar to a rock. Sometimes when they are inside the leaves and the trees, it is very difficult for us to understand. So we have done a particular project, and we have got a good funding for that, and that is still in progress. So where the elephant detection from the cluttered and the occluded data. So we kept a camera in a forest by using the KFRI, with the help of the KFRI, Kerala, the Forest Center, Research Center. Okay, so we got the camera fixed, and we got lot of images, ground images, wherein we took the camera, we took the images. So that is basically done by using and then we have used the seismic sensors to identify whether the elephant is coming near. So whether the elephant is coming near, so we have used the camera, the seismic sensors. So a lot of sensors to identify whether the data whether to identify the elephant is actually there or not, because it could be anything else. So we need to correctly identify whether it is actually elephant or something else. It could be a human also, because the machine doesn't know, right? So there are a lot of challenges was there, and it is still under progress. So there are so many beautiful applications wherein you could take and apply the data. So just understand. So in this particular scenario, as I'm coming from the deep learning background, okay, as from a computer science background, my advice to you is that any data, okay, any data which comes to you, you have to simply take the data, okay. So it could be any sensor data, temperature data, humid data, camera data, video, whatever it is, whatever be the data, that is just a sensor data, okay. That data has to be, so just take the data, that's all. Once you get the data, do a proper cleaning of the data, okay, then you have to convert it into numerical data. So we are, as computer science people, we are going to do only the work up with the help of on numbers. We are going to work on numbers. So whatever be the data, even if it is a image like this, okay, this image has to be converted into pixels. So as you all know, right, you have learned this image processing. So this image will be taken and it has got a lot of pixels in it. So that pixel has got values. How it has got value? If it is a black and white image, it will have either 0 and 1. If it is a color image, it will have the values from 0 to 255. That's all it is. So it's all numbers, okay. So once we get the numbers, it is easier for us to deal with it. Now I need to just take you to the major algorithms, okay, where, okay, the deep learning algorithms that are generally used in IoT applications, okay. So there are n number of algorithms. The best ones available are there are CNN. You would have definitely heard about CNN and RNN, right? So CNN is nothing but convolution neural networks, and recurrent neural networks is your RNN. Then you have autoencoders, which you could very well use, because you know how an autoencoder work. You have got an input and you have got an output. It's as similar as that. Only its distribution is different, or it's kind of a lower image wherein you use this autoencoder, right? Then there is something called reinforcement learning, where we impose some punishment learning. Say if you're not doing good, it's exactly like your father and mother. So if you're not going to score good grades, I'm going to give you some punishment. But if you are getting it, okay, your phone is ready here, okay. So that's all, iPhone is ready or whatever is ready. So it's kind of a reinforcement learning. If you do good, okay, I will provide you good things so that it's an inspiration for you. If you're not doing it good, I will punish you so that you will not do it again. So anyway, it is, win-win situation. So these are all the major algorithms which I have seen, in the deep learning scenario, where these are the deep learning algorithms which are very commonly used, say for network data, okay, for identifying the phishing data in the network, okay. So for all those, basically we use this. So phishing is a very important application, okay. Say if any unnominal data comes in, okay, if you are able to identify, we basically use this recurrent neural network and autoencoders for identifying those. So there are so many applications where the deep learning algorithms are used in your IoT data. Now, yeah, so I will also share this. Okay, this is an important paper. Okay, this is kind of a paper where they have given kind of in and out, okay, in and out about all the security, IoT security related, if you're really interested in deep learning, if you go through this paper, not for the sake of going through it, if you take time and go through this particular paper, you will get a clear understanding about all the deep learning algorithms which are used. That's all I could say, right? So a quick understanding about CNN, then I will go to the demo. Okay, right. So so as I told you, so now you know what is the sensor data when it comes in terms of deep learning. Okay, so it could be an image. So I have captured, say we have captured this image by using a camera sensor. Okay, then as it is a color image, okay, so this 165 by 165 is nothing but the dimension of this image. Okay, dimension of this image. Why this 3 is nothing but you have RGB. Okay, it's a color data, so RGB, so 165 by 165 by 3. Okay, then this is actually a CNN which is done here. So what we are basically doing is we are doing an emotion detection. So we need to know whether this particular lady is angry, fear, or happy, or whatever it is. So we have basically used a convolution neural network here. So basically understand, in convolution neural network, you have various layers in between. Okay, this is pure deep learning, what I'm speaking now. You have various layers in between. So you have a convolution layer, you have a max pooling layer, and you have an activation function, you have a fully connected layer. Ma'am, you're talking Greek and Latin. Yes, I'm talking that now, but you will be at least familiar with this Greek and Latin in the next few slides. So these are the basic, say I'm talking about CNN. Okay, I'm just talking about CNN, convolution neural network. Okay, I will just introduce you with one so that you can explore later with the others. Okay, so in convolution neural network, you have got basically various layers. One is the convolution layer, one is the ReLU layer, one is the pooling layer, and the other one is fully connected layer. Okay. So what is the use of all these layers, ma'am? Yes, it is very simple. It is nothing but all these layers are basically used in order to extract the features. Okay. So the use of all these layers is nothing but as simple as that. They all will help you to extract the features from the image which you have taken here. So all this are nothing but extracting all the features. Then what happens here? Yes, some prediction or classification is done. Okay, these are the prediction and the classification layers, the processing layers, which help you to identify whether this particular lady's photo is happy or sad or whatever. Okay, so how am I extracting the features? You can definitely, if you're interested, you can definitely go in detail, but I will just tell you. Okay, in the convolution layer or in max pooling layer, okay, we extract the features with the help of a filter. Okay, I don't know whether you have already heard this. So everything is a matrix. Okay, just understand everything is max and it's matrix. So what you're going to do is that you are going to apply this. This is your original image. Okay, this is your original image. You are going to apply this filter. Say I want to identify the lip portion of the lady. Okay, because I need to know whether she is sad or happy or whatever it is. So this is a filter, okay, which extract the features of the lip. Okay, so this is a filter which is applied upon here. Okay, so what am I doing? I'm doing a simple thing. I'm just going to do, this is the original value 1 and this is the filter value. This is the original value and this is the filter value. First value is 1 and this is the original value. This is the filter value. The filter value is 0 here. Yes, I have used 0 here. This is the original value. This is the filter value. Yes, this is 1. So what I have done is I have applied this filter upon the first portion of the data. Okay, then what I have done, I've done a simple, summation. Okay, so 1 plus 0 plus 1 plus 0 plus 1, everything calculated together, I got the value 4. So what am I basically doing? I am reducing the image. So reducing the image in such a way that I got this value 4. That means this 4 represents that, okay, she is smiling. Okay, there, the intensity of the pixels are more. That means that, okay, she is either smiling or she is either laughing. So it comes to that category. Hope you are able to follow me, right? So this is your original image. You are applying some filter upon to it and you get some intensity values. According to the intensity values, you will get, that is called as a convolved feature. So this is the first kind of the feature which you get when you're applying a convolution layer, convolution operation over to the image. Now, can we stop here, ma'am? No, we cannot stop. Now, what we have to do is say, this is our picture. We don't have to worry about this extra parts, right? We don't have to worry about this extra pack. So I was just talking about this intensity. So see here, what I'm doing is I do have a rectified linear input unit. Okay, I do have sigmoid function. So I do have, softmax function. Okay, there are so many different functions like that. When you apply the function, always understand it helps us to identify the boundary where the high intensity values are there. So this is again a feature map, but this is a feature map. This is also a feature map. Okay, and this is also a feature map, but this is a convolved feature map because it is called as convolved feature map because we have applied the convolution layer, convolution operation. And this is called as an activation function feature map because from the picture, it actually identified the boundary, the decision boundary of the data. Okay, now this is another thing. This is called as pooling because I need to clearly identify whether it is the beak of the beak of a bird or this is the tree or whatever. I need more inner detail. So I'm extracting even more features. So again, what am I doing? The real operation which I'm doing is applying filters, but I'm applying filters in such a way that I get exact features. Okay, this is a beak. Okay, this is a tree. Okay, so like that, I am applying the different features. Now, once so these are the final intensity pixel values I get. So once I get this, what I need to do, I need to flatten it. So there is an operation called flatten. So that is nothing but I'm converting my multi-dimensional data into a single dimensional data. Okay, now what I need to do, the next one is dense operation or fully connected layer. So these are all, what I'm telling is these are all operations in convolution layer. Okay, I know it will be a bit of vague for you now, but just understand so that when you go later, okay, you will be in such a position that, okay, we have heard somewhere. Okay, so so this is your one dimensional data which you got from here, this one. Okay, so what you're going to do is that you have various hidden layers wherein you do the fully connected layers. These are the processing part or the prediction part. So what will it predict? It will predict whether this is a bird or a dog or a cat. Okay, so this is the whole structure. This is what we are going to do in our demo. Okay, so we have got an image. we are applying some convolution operation. So whenever someone says that it's a convolution operation, you should understand that it is feature extraction. What are you doing? Basically, you're applying filters. Okay, ma'am, how will we apply? There are already a lot of filters available. So according to your application, you need to just select the right filter. So filter in ReLU, ma'am, in activation function, what are you doing? Yes, you need to do filter. And in max pooling layer, what are you doing, ma'am? Yes, you have to apply filter. So these three are nothing but feature extraction. So all these things are nothing but for the feature extraction. By these three layers, what happens is you get the extract features. Then you basically does something called flatten operation here, which converts this multi-dimensional data into a single dimensional data. So once you get the simple dimensional data, okay, I apply a lot of fully connected layers so that I finally, so as and when you add more number of layers, you get your efficient output here. That's all it is. Or if you add more number of feature extraction, so you're extracting features in such a way that, okay, when once you come to the fully connected layer, my prediction is really good. Okay, so this is the model which you are going to build. Okay, so this is the model which you're going to build. Okay, now I will go back to my demo, because without showing demo, my whole presentation will not be complete. Okay, so here what I have done is, instead of what is that, the bird data set, I have taken the cat and dog data set. This is a beautiful data set which is available. So I have got, see, this is the test data set. Okay, and I have got training data set. So in training data set, I have got a lot of cat images. Hope you are able to see my screen. There are a lot of cat images. Okay, and I have got a lot of dog images. So for making the process simpler, I have reduced the data set to 40-40. Okay, so that is up to you. And here you have got, this is my test data set where my model will work upon. Okay, so this is the test data set. And I have also got validation data set. Validation, this is my for validating it. Okay, for validating it, I will give the dog, I will create a particular model, and my model has to predict it is dog. Okay, my model has to predict it is cat. So that is what we are going to do. Okay, so we will create a particular model by using convolution neural network. Okay, then we will give this image and we will see whether our deep learning model is actually predicting it correctly or not. So how is IoT related here? Yes, we have used a camera sensor to get the pictures of the cat and the dog, and we have put it, this is our data, this is our raw data. So we have taken our data, and that data we are going to process. Okay, so now when it comes to the tools where we are going to use this deep learning architecture, it's as simple as that. Okay, so normally this is your Google Colab. Okay, if you have a Gmail account, that's enough. Okay, deep learning is simple. If you have a Gmail account, everyone will have a Gmail account, right? So you would have already seen something called Google Colaboratory. Okay, you have to simply type Google Colaboratory in your Google search engine. Okay, it will ask you for your corresponding Gmail account. You can just start working with. Ultimately, that is nothing but online Jupyter notebook. Okay, it's an online Jupyter notebook. There is a tougher way of doing it, like you can install the Anaconda prompt, and then you could raise the, you could open your Jupyter notebook from there, or you could use any application. So here the thing is that, the framework which we basically use is the TensorFlow framework, which uses the Keras package over to it. Okay, so I'm basically using this Keras. So don't worry about what this Keras and TensorFlow, because everything you have to just search and find out. These are some packages which helps you to understand. So by the end of this example, you will be able to understand, okay, how this works. Okay, so I think it's going to be time, so I'll just fastly go. So say understand deep learning model. So I will tell you how simple it is. Okay, so this is a deep learning model, okay, which we are going to develop. Okay, so for deep learning model, so I have taken a Google Colaboratory. So my tool is ready. Okay, my tool is ready. Now I told you I'm using Keras. So whatever I am going to do, everything is available in the package called Keras. In the package called Keras. How will you install Keras? It is just install Keras. That's all. Okay, that's and all. We will learn it in another session. So see, understand. So this is our data. We have to build this particular model and we need to get an output. This is our aim. Okay, this is our aim. So now understand, in this particular model, say I am using a convolution layer, then I'm using an activation function layer, then I'm using a pooling layer, then followed by a fully connected layer. So all this are done in a sequence. Okay, so I need to first apply convolution, then apply ReLU, then apply max pooling. So there is a sequence which I follow. So there are different models available in Keras, but the model which we are using here is a sequential model because that is the simplest model. Okay. Now, do we need to develop this convolution model from the scratch, ma'am? No need at all. Okay, you have already there, okay, with lot of parameters available for con2D is an inbuilt function in Keras. Then what is the work, ma'am? That is what I told. It is all simple. Okay, so you have something called con2D, okay, which is for images, and you have con3D for videos. Okay, you are simply importing this con2D from Keras. Okay, then do I need to do the max pooling separately, ma'am? No, it's not needed. That is also already there. Okay, then do we need to, so what will this max pooling do? It is nothing but applying some filter. Okay, so what these two will do, this two will simply extract the features. And what will this flatten do? Flatten is nothing but it will help you to convert this multi-dimensional data into a single dimensional data. That is what we are doing, right? So what is happening here? You have this flatten also already there, so you don't have to worry that also. Then what is this dense? Dense is the other name for your fully connected layers. So that module is also there. Okay, then what is this image data generator? Say image data generator is nothing but if you want to do some resizing of your image or reshaping your image, okay, if you want to do some pre-processing, if you want to do some operations upon the data, then you need to use this image data generator. So everything is already there. What you have to do, you have to just use it. That's all. Okay, now what I'm going to do is that next one is nothing but, so now you know everything is available in Keras itself. Now we are going to build this whole model. This is our model. Okay, this is our whole model. Okay, so we are going to build the model. So what is our model? Okay, so what we are going to, so this classifier is the name of the model. Okay, we are going to generate a convolution neural network model whose name is classifier. Okay, whose name is classifier. And my model should be in what way? My model should be a sequential model. Okay, so is that sentence very clear? It's all very easy. Now, what is this, ma'am? Okay, how will I use this convolution layer? Now my next step is nothing but I need to apply a convolution layer. How will I apply the convolution layer? It's as simple. Just provide the parameters. What is this parameters? Is it really rocket science? No. Okay, it is very simple. It is 32 filters are used. You are in convolution neural network. Convolution layer. You have already seen. You are applying some filter. So I'm using 32 different filters. See here. Here I'm using 32 different filters. So am I using one particular filter? No, I'm applying 32 filters. Okay, that's all it is. So 32 filters, and what is my filter size? It is 3 by 3. And what is my input shape? Okay, it is an RGB image. So that's why this 3 I told you, right? RGB image. And my dimensions is nothing but 64 by 64. So my size of the image is 64 by 64 and it is RGB. So 3. And what is the activation function? So do you have to give this activation ReLU? See here in this we are using ReLU. So this is actually part of your convolution layer. So you don't have to even do that. So what is this ReLU? You are applying the ReLU function upon to it. So this is your convolution layer, as simple as that. Then when you just simply add that to your classifier, so it's kind of a clear box. So now you are adding the first layer, convolution layer. Now to the box in the sequence, you are going to add what? You are going to add max pooling. You are going to add max pooling. Okay. So how will you add max pooling? It is even simpler. Okay, it's even simpler. It is just that you need to give this filters. Then you are going to flatten. Okay, what is the next one? You have to flatten, right? So what you have done is you're flattening the layer. How will you do that? You're adding the next layer onto the model. Then what is the next one? You are having various here, instead of giving all the 3 different fully connected layers, we have used only this layer is not there. Okay, we have just given that first layer. Okay, two different layers. We don't have here 1, 2, 3. Here there are 3 fully connected layers, but in our example we are giving only 2 layers. So here the first layer is nothing but the units is 128. What is this units? Units is nothing but the number of nodes in your fully connected layer. Number of nodes in your fully connected layer is nothing but, see here it is all the same. Here it is less, right? So that is nothing but number of layers in the fully connected layer. Say I want just one output. I want you to tell me whether it is cat or dog. Okay, so this fully connected layers are also associated with the functions, activation functions. So what will this activation functions do? It will simply stick on to the decision boundary. So as in your so this is your model. So now you have built your convolution neural network. Okay, so it has to be sequential. It should have a convolution layer. It should have a max pooling layer. It should have 2 fully connected layers. So your model is ready now. Now what you have to do, as in your computer programs, you need to compile this particular model to see whether there is any error. Okay, so compiling the model usually happens with the help of, there is something called optimization function. Just understand at this particular level, because you have to always reach the global optimum. So just understand that it is somebody to help you understand what is the loss of your model. Okay, what is the entropy? Entropy means it will always show you the error rate. Okay, what is the error rate? Whether your model is really good or not bad. For you to understand that, you have something called compile. Okay, you are compiling the model in such a way that you need to understand that. So after compilation, what you have to basically do is, okay, you need to fit the model. Okay, you need to fit the model. Okay, then the next one is nothing but you need to predict the model. You could see here, you could see one line, fit the model, then you could predict. So these are the steps when it compares to the model. Now, one more thing what you could do is that I told you about this image data generator. So image data generator basically helps you to rescale or resize your image. Okay, so this part is basically the pre-processing part. Okay, which you do, these three steps are the pre-processing part which you do upon. So what is the pre-processing here? So you have a data set, you need to basically change your data set into testing set and the training set. That's all it is. Okay, you're dividing your whole data, say 80-20 or 70-30, whatever be it, you are dividing the data as such, and you are applying the model. You are applying the model upon the training and the testing set. Okay, so when you apply the model, when you fit the model, the right term to be used is when you fit the model, what happens is it will run the model, it will train the model upon the training data set. Okay, so in training data set, what happens is there are various epochs. Okay, epoch 1, say, how can I fix my epoch as 10, ma'am? Yes, it is just due to your, it is up to your, what is that experimental process. Say, see here, you can see the accuracy of the model here. Say, I could even keep the model's accuracy as, I could even keep the epoch as 5. Why? Because see, after this 5th epoch, my accuracy is already 1. Okay, my accuracy is already 1. That means that my model is basically overfitting, because there is no major difference. Okay, there is no major difference to my model. So I could even stop the epoch as 5, because I have trained this model so many number of times. That's why it gives you accuracy like this. Okay, I would have run this some 20 to 25 times. So that's why my model is so accurate. Okay, so I need to basically change my data set now. Then only it will give you different results. So understand. So this is nothing but modeling. You have now modeled. So your model is ready. Okay, model. So at this particular time, you can use that particular model for some other applications also. Now what you are doing, that model, with that model, you are predicting the test image. Okay, you're predicting the test image. So what are the test images here? You have 2 images here. Okay, you have 2 images here, the cat image and the dog image. Okay, the dog image and the cat image is there. So we can predict. So 2 is nothing but cat. Okay, the second, the one is nothing but it is dog. Okay, it is predicted. It's as simple as that. So this is basically, so now you know that deep learning or programming a deep learning is, it's very simple. Okay, because everything and anything and everything is already available there. And I just want to take few minutes, just understand, this is basically a sensor data, temperature data. We have basically taken a temperature data. Okay, and we have actually identified how many times the the room admin, okay, what is the in temperature and the out temperature of the data inside a room. Okay, where he stays. So this is kind of, okay, when he goes out, okay, what's the data? Okay, what when he comes in, what is the data? So this is kind of representation. This is kind of a visualization I just wanted to tell you. So here we have actually taken the data. Okay, this data is nothing but a temperature data. So this is the data set which we have got. So from this data set, we have cleaned the data in such a way that we have just taken the temperature, the out and the in, and the date. So I know that, okay, at this particular date, okay, what is the in and out temperature in that particular room. Okay, now then I have analyzed that particular, say, this is basically useful, when it comes to the factory setups and everything. Okay, you could use that. And so see, understand, okay, there are so many. Now I will just tell you one more thing. Where can you get this data? Okay, all these data are available. So you need to know, if you want to work, you need to work with the data, right? Data sets. You need to know where the data sets. Where can you get this data sets? Understand? Okay, I will post this in your this thing as well later. Okay, see, you have got lot of data sets available. Okay, so this is a cigar data set. Okay, cigar data sets and the commercial data sets. There are so many data sets available here. And in the Kaggle, when you go to Kaggle, okay, there are n number of data sets available wherein a lot of works are not there. Can you see? A lot of works are not there. So kindly utilize all this. Okay, in GitHub. Okay, I will send this link as well. In GitHub, you have got n number of smart. It is actually divided into home activities, smart cities, okay, utilities. So there are a lot of in UCI, okay, UCI data set. Okay, then you have in KDD nuggets. And when you go to Kaggle, I really suggest you to use the Kaggle framework, because in Kaggle framework, there are a lot of algorithms which are already there. So you don't have to even. So for you to get a hang of deep learning programming, what you have to do is go to Kaggle, create an account. Once you have an account, just start working on the data, because you can simply click and edit. So whenever you have a you have a program, you have to simply do click and edit, so that you don't have to even install anything in your system. So you cannot give the excuse that I don't know how to install the things in my system, because it automatically creates you a Jupyter notebook which is provided by Kaggle with all the data, that same program in it. Okay, you have to simply click and run this. There is my network is a bit slow, that's why you can simply click and run the programs. It's running here, see. So you can just click and run the program and see how it basically work. Okay, so it asks you to enter the data, so you can just enter the data and see how it basically work. Okay, so it's as okay, so this is so under DL is basically connected with IoT. Okay, how DL is connected with IoT. So how basically you could use this DL algorithms in your IoT applications, and where you can see here. So this is actually the IoT predictive. Somebody have done some particular program. Okay, this program, you don't have to even anything installed in your system. You are going to use the Kaggle server to run this and see how this. And if you want to save this program to your system, you could also download the program here. Okay, and you could use it in, you can improvise it in your own way, and you can use it. Okay, or you could simply want to save your version, that is also available. So utilize Kaggle so that if you are really interested in deep learning projects using IoT. I think I have given a lot of overwhelming data to you, but I really wanted to cover this, so that's why. That's all from my part, Shanmugesh sir.
Thank you very much, madam. Now it is up to the
Yeah.
audience. Any
Yeah,
queries,
yeah, yeah. If you have
clarification?
any doubts, I'll be really happy to share
You can show
with
your
you.
face, means it will good for us, ma'am.
Oh my God, really? Okay. So it'll be like a homely look. Okay, sorry for that. Yes. Hi.
Now, any
Okay.
questions from the audience?
So, yeah, any questions? And I could also provide my email ID. So if you have anything, can you share your email ID? Of course, I will share my PPT to Shanmugesh sir. So how can select the activation function while designing your neural network architecture? Yes, it is by trial and error. You are right. It is by trial and error. But understand, say if you are using softmax, if you are basically going for the probability based, so softmax function basically gives you the probability of, it's kind of your MLP. You don't know, but I don't know whether you know this MLP function, like your what is that, the mode. It's kind of your mode. Say if you want to understand, say we will take the traffic data. So if you want to understand which mode of traffic is used at the prime time of the traffic, so you want to know, say the buses goes more, so you have to get the mode that, okay, you have all the other traffics available, but still you need to understand that, okay, car is the one which has gone through that particular time. Okay, car is the one which is used, so you could go for softmax. Okay, so it depends upon, so this each and every functions, its decision boundary is different. So decision boundary is nothing but either 0 to 1 or -1 to 1. It's just that. So where you want to, so according, that's why it is very important why you visualize the data before and after. So when you visualize the data before, you will have an understanding whether you need to fix the data to 0 to 1 or -1 to 1. So if you have more negative data, you can fix your data from -1 to 1. So you can decide your decision boundary accordingly. So ReLU, and also there is so many concepts there, like vanishing gradient descent, because ReLU has got this vanishing gradient descent, which could be avoided in sorry, sigmoid has got this vanishing gradient descent, wherein you could use this fast ReLU. So there are so many factors involved, so according to your applications, and it's mere by trial and error. So according to how efficient your results has to be, you need to use this activation function. You have to decide upon it. Then thank you, Alphonse. Thanks a lot. I've experimented with Google College. Is the same to run my PhD work related? Of course. Okay, I do my PhD work in that. So of course you can rely upon it. But only thing with this, when you're trying this deep learning, in the Google Colab, one issue which I have faced is that you will not get that GPU and TPU facility available always, because when more number of people are using this, because nowadays no number of people, everyone now working online. So when more number of people working online, so you will not get that utility of NVIDIA GPU. So I do have my system which is completely fed with the NVIDIA GPU. So I run everything in my own system. So always understand, keep it in mind, if your system configuration is less, say if you have an i3, if you have a very minimal configuration, don't try running the deep learning programs in your system, because your system will crash. Okay, so you could either use Colab or Kaggle. You can create an account. So they takes the burden. So you don't have to worry about processing everything in your system. So they takes the burden. Whether the Colab using my Python? Yes, of course. Then, thanks, Michael. Then any other questions? There is no major security issues, Alfonso, as of now. Okay, I have not faced anything, unless or otherwise. I don't know. Is there kind of such a secretive data with us, even if it is PhD work? Because even by the time we get to publish the things, our work sometimes gets obsolete. So it's all our luck. Okay. Then any questions? So I will share this PPT with Shanmukesh sir. So please utilize that. You could from BTech projects to your research. Okay, it will be really useful for you, and I will be giving my email ID in that. If anything, if any help I could do from my part, I will definitely, even if I don't know, I will search with somebody or check with someone. I can always get back to you. Yes, thank you. So yeah, so thanks a lot, Shanmukesh sir and Vishwajyoti, because engineering college, for giving me this wonderful opportunity. And thanks Martin sir for giving this wonderful intro. Thank you so much. If in case I am of any help to you, I'm always available. Thank you, sir.
Thank you very much, madam. Hope to see in offline in our college itself, future.
Oh, yes, sure, sir. Thanks a lot. Okay.
Thank you for the wonderful
wife.
presentation, madam. Now let me invite Martin sir for the vote of thanks.
Thank you, Senior Ma'am, for your wonderful session. Actually, your session on the various applications of IIT using DL was outstanding. On behalf of the entire Vishwajyoti College of Engineering and Technology, I extend our sincere thanks. Thank you. Thanks a lot.
Thank you so much, sir. Thanks a lot.
Thank you, madam.
Thank you. Thank you.